Welcome back to our series where we are covering the M formula language, the language that is used behind Microsoft's mashup engine and being leveraged in Power BI and Power Query. So, in our last video, we kind of got our introduction into what is the M language, where is it used, what kind of language is it, and really kind of just defining, what is a query. Uh, how do we think about the variables in this type of language, and just very high level things. So in this video, we're going to kind of pick up, I would say, where we were with the queries. And so we understand kind of the structure behind a query, but now we're going to go into the actual data types that we have at our disposal that we can use inside of Power Query. So I'm assuming at this point, everyone does have syntax highlighting. I did explain in the last video how to get syntax highlighting if you are on an earlier version of Excel, or if you don't have access to Power BI, because most time Power BI is reserved for business. So with that being said, let's jump back into it. So at this point, let's just kind of recap a little bit. We understand that a query, or an M formula language query, is simply defined by kind of two keywords. We have the let keyword and the in keyword. The let keyword is where we basically define each of our variables. So in this case, this is a very simple query. It has one variable, it's called source, and that variable equals an expression. That expression is simply a function that takes an input and transforms it in some fashion. So in this particular example, it's going to take the text hello world and it's going to make it proper case. So it's going to make it hello and a world. So if I was to drop this in my Power Query editor, so to access the Power Query editor, you go down to first you go to the data tab, you go to get data, and there's a couple ways to kind of do this. If it's a blank query, in the sense of you're writing it entirely from scratch, you're not going to import or anything like that, you can go from other services down to blank query. And if you click that, it will open it up for you, and it will give you kind of a blank starting page. If you don't do that, then you would have to, once you're inside the Power Query editor, go down to new sources, other sources. It will, there we go. And then down to blank query. So that's the other way to kind of write a query from scratch. So once you're here, if you are on an earlier version, if you're on a newer version of Excel, you will have syntax highlighting. There's a couple options that you can kind of define about your editor. For example, you can display line numbers. I like to have that on. You can have white space. So this will actually let you know how much white space you have. It's kind of up to you. Mini wrap. Oh yeah. So this is one where if you've got a really, really long query, you can kind of just easily navigate instead of having to use the full scroll bar. Most time you're probably not going to need that. And then enable word wrap. So if you have a query that spans all the way across a couple thousand characters, do a word wrap. It's a lot easier to work with. So at this point, you will have syntax highlighting. You can just paste it in. And then usually, if you hover over a particular function, so in this case, it will tell you what the function does, and it will tell you the arguments for that particular function. So the text proper function does require a text argument, and then there's a couple other optional arguments. We'll kind of go over that as we encounter functions that offer that, and then things along that nature. So you've defined your variable. It's equal to an expression. Let's see what the output is. You guessed it. It's really simple. It's simply, and unfortunately, I can't zoom in. I was going to try to zoom in. It's just hello world proper case. So that's a really simple query, and that's kind of how it works. So continuing on, we're now going to start talking about data types really, or kind of kind of two categories. There's primitive values, and then there's functional value, and then there's structured data values. So kind of different things, but we'll start with the primitive values. So again, this is just coming from the Microsoft documentation. Primitive value is a single part value, such as a number, logical, text, or null, primitive value. A null value can be used to indicate the absence of any data. Now, if you go on the documentation, it's going to look a little bit different, but I kind of wanted to make it what I would say is more realistic in a sense. If you go here to expressions, values, and let expression, and you go down, you'll see examples of primitive values. So they're kind of giving you more of like visually, what does that kind of value look like? So if it's a date time, naturally it's a date and it's a time. If it's a date time zone, it's a date plus time plus a time zone. However, if you were going to write that in a literal form inside a Power Query, what would that look like? It's a little bit different. So depending on the actual primitive value that you're working with, it changes a little bit to make things complicated, right? Nah, it's not too bad. So for binary and pretty much any of the duration, date, and time primitive values, you actually have to use the pound sign, the name of the primitive value, so in this case binary, and then you just pass through whatever it needs to be. So for binary, it requires a list of like an actual binary value. If it's a date, it's the year, the month, the day. If it's date time, year, month, day, hour, minute, second. Date time zone, everything else, number of hour offset, number of minute offset, duration, number of days, number of hours, number of minutes, number of seconds. Logical can be true or false. It's usually highlighted blue, and it is lowercase because the M language is case sensitive. Null, you can just write the null keyword. Numbers come in a lot of different forms. So you have whole numbers, negative, positive, decimals, and then you can even do scientific notation if you so choose. Maybe you can't do I don't know. I've never actually tried the scientific notation, to be honest. I'm going to try right now and see what it gives me. A little highlight error, we know. So is it 2.3 e to the 5? Yeah, looks like it's good. So yeah, you can use scientific notation too. That's pretty cool. I think that's scientific notation. If not, I'm going to sound like an idiot. Text. Text is simply surrounded by quotation marks, and then finally time. It's very similar to date. You just define the hour, the minute, and the second. And then if I just run this as is, you'll see over here on the right side all my steps, and you'll see the output and then also what it looks like in the formula bar. And I can kind of just navigate up. You can kind of see really, that changes a little bit, but nothing crazy. This is the duration. This is my date time zone. This is my date time, my date. Binary is kind of interesting, actually. So if you want to see it, you can actually do it a couple different ways. You can open it as a text file, CSV document, so on and so on. But basically, you convert the binary into something else because Power Query doesn't kind of want to work directly with binary. But if you were to open this, it's going to first prompt you like, hey, do you want to insert a step? You just say yes, and you'll see what that looks like as the text component. So I don't know if you can, I'm not going to do that. But anywho, that's how you would work with binary content. And technically, whenever you import an Excel file, it's going to be imported as binary, the content of it. So you work with it, but a lot of times you're going to work with it indirectly. You kind of get the end result of any kind of binary transformation. All right, so those are primitive values. We also have a functional value. So this is kind of leveraging that functional programming language structure. So a function is a value which invokes with arguments produce a new value. Functions are written by listing the function parameters in parentheses, followed by the goes to symbol, which is an equal, And then I think that's, I don't know, less than sign. We'll just call it that. And then followed by the expression defining the function, right? So here is an example of a functional value. So it's very similar to, it's a regular query. I have one portion where I define my function. So in this example, my function takes 2 parameters. And what it's going to do with those 2 parameters is it's going to add them, and then it's going to divide the sum of those 2 parameters by 2. So here I define my function. Here I call my function. I set it equal to a variable called source. I call my function and I pass through the arguments. And then I output the source. So very straightforward. That's a simple function. Trust me, functions can be very complicated very quickly, depending on what you're trying to do. But for simplicity's sake, we'll keep it simple. So with this one, I expect my output to be 3. Lo and behold, it is 3. But do notice in the formula bar, it does change a little bit. It actually does show you the actual function with the input values. So pretty cool. Now comes the fun part. I actually like these ones a lot for some reason. I don't know why. So next we're going to talk about structured data values. They come in 3 different flavors. We have a list, we have a record, and we have a table. Let's talk about a list. A list is a zero-based ordinance sequence of values enclosed in curly brace characters. The curly brace characters, denoted by 2 curly braces, are used to retrieve an item from a list by index position. They provide some content. I'll just go over it, but it's regardless. Power Query M supports infinite list size, but if a list is written as a literal, the list has a fixed length. For example, list 1, 2, 3 has a fixed length of 3. So you can have infinite list size, but if you actually write it out, it's going to be a fixed length. So if I wanted to work with a list, for example, what are some things I can do? Well, first, I want you to know that a list does not have to contain all the same data types. It can contain a text, a number, whatever you want it to be. You don't have to have it all be the same data type. You can. So in this example, I have a list of numbers. I can also have a list of lists. So in this case, I have a list that has another list, another list, another list, and also these lists can, again, follow the same rules up here. They can either have all the same data type or they can have mixed data types. You can also have a list of records. Records we'll get to next, but basically they're just fields that have names and then values associated with those field names. If you want to index a list, you would first define it, and then you say, pass through the index. I want the 0 element. So this, in this case, would return A. I can also index a nested list. So in this case, I want from the first list in my list of lists, I want the second element. And I just realized that's actually wrong. It's technically 2. My apologies. But from here, let's see what this would look like inside of Power Query. Hopefully everyone's getting it at this point. I'm trying to go step by step. So everything looks good. Let's see what we get. So I'm expecting 2. Yes, 2. Okay, so that's the result. Keep in mind, if you do write it a little bit indented, it will actually it will wrap it in the actual formula bar. So just keep that in mind. This is me indexing another one. This is my list of records. This is my list of lists. So if you actually select each individual list, you'll kind of see a preview of it down here. My list of numbers and my list of different data types. With records, again, if you select it, I don't want to navigate to it, I just kind of want to preview it. You'll see that preview right down here. All right, so that's list. What about records? A record is a set of fields. A field is a name value pair where the name is a text value that is unique within the field's record. The syntax for record values allows the names to be written without quotes. A form, also referred to as identifiers. An identifier can take the following two forms. So identifier name, such as order ID, and then identifier names such as # wrapped in quotation marks. Today's data is whatever it might be. So what they're saying is you can basically have a record name. Well, you can have a record field that is either including spaces or not including spaces. Me personally, I try to avoid spaces if at all possible, as you probably can tell. So what does it look like to work with records? Well, if I want to define a record, first it's the name of the field and then the value you want associated with it. And again, you can have mixed data types in here if you so choose. You don't have to have them all the same. And you can also, in this particular example, you can have nested records. So you can have a record within a record. So I kind of took an example from Microsoft, which says, hey, you have an order and that order represents another record, which is the product ID and then the amount for that particular product. Little different if you want to access a particular field, it's simply the record object. And then it is the name of the field surrounded by square brackets that you want to access. With a nested record, it's the same as nested indexing for list. It's just define what you want. If that object that is returned is another record, you can then just keep kind of going deeper and deeper into the actual list itself. So again, let's take a look at it and see what it looks like inside a Power Query. All right, I'm going to paste that in. Everything looks good so far. No syntax errors, so I'm happy. All right. So we have my record. So this is how records appear. These are vertical. And then you kind of notice if you actually select it, it shows you the value down here. I kind of like to think about records as dictionaries in a sense, because you have this key value pair association with it, which does make it kind of similar to a dictionary in that regard. And then you also have what we call a nested record. So if you select over this one, you'll notice that, again, you'll see kind of a record preview down here. Obviously, depending on how nested it is, I've never gone beyond actually 2 layers, but I don't know if it's actually going to preview everything. If you want to access a particular field and return that value, you just pass through the name, and then the same if it's a nested record. So that's records. On to the next one, tables. A table is a set of values organized into named columns and rows. A column type can be implicit or explicit, meaning you can define it or not define it. You can use the # table to create a list of column names and list of rows. A table of values is a list in a list. The curly brackets are also used to retrieve a row from a table by index position. So what does that look like? I have my table. I'm defining it with the table keyword, or basically the table literal. And then with this one, the first row is my table column names. And then I have this second one, which is it's kind of a little bit confusing, but if you look here, this is technically 2 other rows within that second list. And so the first list is column names, the second list is the actual row values, and then each one of those rows is represented by another list. So again, depending on the complexity of your table, if you were manually writing this out, it could probably look really messy. I can also be much more explicit with my column data types. So in this one, I'm not really defining anything about it. I'm just being implicit. Power Query behind the scenes would kind of come up with what it thinks is the proper data type. With this one, I'm being very explicit. I'm actually saying type table, and then I pass through this record set where I pass through the column name as the field name, and then I pass through the data type that I want that particular column to have. So that's the field value. In this case, I have 2 numbers, a text, and then finally a number. If I want to index my particular table, it would be just going through. And then obviously, if I wanted to go one step further, I could go and say, hey, give me the first element of the first row. All right, so let's see what this looks like inside of Power Query. Bam. Okay. So looks good. No syntax highlighting. Got my little comments. Good to go. All right. So looks good so far. You can see here, this is our table structure. Notice that there is no defined data type, and you can kind of tell that because it's right now just ABC123. That basically means it's everything. This one I've been more defined. I've actually defined each particular data type. And then here is me indexing it. I could even write from the formula bar if I wanted. I could say, actually, hey, no, maybe I can't. Maybe not. Oh, I think that's because that's returning the actual field name itself. I don't know. I'll leave that for another day. All right, so that's tables at this point. So from here on out, I'm just going to be talking about stuff. I'm not necessarily going to be actually coding anything. So you don't necessarily have to stay around for this part of the video. I encourage you to if you're more interested. I think you should, because I think it's just nice to know. And it's just one of those things where if you don't know how to do it and you're trying to do it down the road, you'll thank yourself if you know how to do it. Okay, so type conversion. Power Query does allow you, or the M language does allow you to basically convert anything to anything else. So for example, I can convert a number from text, and basically everything here is what the type conversion looks like. You'll notice that these are pretty much all functions that you would find in the documentation. So for example, if I went down to number, where's number? Number. You'll see number, where is it? Number from text, number from. These are just different types of functions that will do data type conversions for you. They do offer int32, int64, single, double, decimal, currency, you name it, they pretty much have it. Same with text. You have text from, value is any, and it's just saying it can be anything. You can pass any type of data into these functions. At a certain point, it's probably not going to make sense, because if you're passing through a string and you're trying to convert that to a currency, so like if I'm trying to pass through Alex and I'm trying to convert that to a currency, it's probably going to return an error. You have logical. So logical will return the value of true or false from a text value, returns a text value if you want to basically convert that logical value into text. And then you can also return logical from value as any. So again, this will make more sense once we actually leverage it down the road. All right, date, time, and date time zone. Lots of date times. So you can do from text, to text, from, and then also this one's kind of special, to records. So you can actually convert a date, time, and date time zone to an actual record set where it contains the different parts of that particular data type. All right, so that's data type conversions. Now on to operators. So there's plus operators. So for expression, it's just 1 + 2. And then you can add certain different types of data types. So like duration and time, you can add together. Combination operators. So you can use the and symbol or ampersand to do text concatenation. If you use that ampersand on to list, you will get a list concatenation. And if you use it on two separate records, you will get a record merge, which is a single record with both fields and both field values. All right, so those are kind of just different types. These are lists of M operators. So you have greater than or equal, less than or equal, not equal. Logical operators, so or, and, not. So 5 or 6, 6 and 7, not 6. Use these in if conditions normally. Number operators, plus, difference, product, quotient, unary plus, I think. I don't know. Negation. Text operators, ampersand is concatenation. List, record, and table operations. You have equal, not equal, concatenation, square brackets to access fields of a record by name, access an item in a list by its zero-based numeric index, so that's squarely brackets. Type, compatibility, and assertion operations. So is the value I'm working with a number? If it is, returns true. If the type of X is compatible with Y, then it returns false. Returns false if the type of X is not compatible with Y. So if they're compatible, it returns true. If they're not compatible, it returns false. So the expression X as Y asserts the value is X compatible with Y as per the is operator. Date operators, this is just a lot of different stuff. Basically, all it's saying is like, hey, if I was to have time on the left and then duration on the right, what would my output be? Well, in this case, it would be a date offset by the duration. If I have a duration on the left side and time on the right side, I have a date offset by the duration. So it's the same. Time on the left, duration on the right, date offset by negated duration, duration between dates, so on and so on. Date time operators, date time zone operators. This will all be on the code that I'm going to be posting to GitHub. So I do encourage you, look over it briefly, but for the most part, you're not going to have to deal with it until you actually encounter a problem that leverages that. So with that being said, I went a little bit over. That's okay. All right, so with that being said, that does finish this video. So if you have any questions about data types, structured data values, operators, type conversion, what else did we cover? Indexing, function values, primitive values, anything like that, please put them down in the comments below and I will try to get back to you. Also, if you could, please make sure to like the video. We always appreciate the support. And if you're not already, please make sure to subscribe to the channel so that way you get regular updates as we release new videos. So thank you again for watching, everybody. In our next video, we're going to be covering the topic of records in a lot of detail. So we'll see you in the next video.